just give you a brief introduction. This is on polarization, light intensity. And polarization. So, what we're going to do is the first part we'll look at, we have a light source. And we're going to have a sensor. And we're going to be a distance away, R. And we're going to measure the intensity of the light in watts per meter squared, a distance 10, 20, so on. So this is the lab handout for this. We'll be measuring that and seeing how the intensity changes as we go farther and farther away from this light source. So that's the first part of Lab 9. And I'll go through the whole data, taking the data for the lab, but this is the first part and how this actually varies. The second part, on polarization, I talked about that. If we have, remember, light is a transverse wave. So as light comes towards you, it's transverse, it's going to be vibrating in all directions. So it looks like this, sort of, as it's going that direction, but if it's coming toward you, it's going to be vibrating in all directions. This is unpolarized. All right. Now, if we then send it to a polarizer, like this thing, polarizing filter, what will happen is all the light will be polarized in one direction. All right, this is 0, this will be 90. If I go around 180 and 270 and back to 0 again. So what I do is if I have one, right, normal light is not polarized at all. So normal sunlight, the lights in here are not polarized, so as I rotate this, we see nothing happen. Now, on the other hand, if I take the light coming through this one, as it comes to the camera, is polarized. So if I take a second one and rotate it around, notice as I rotate it, light goes from white to dark, and then back to light again. So this is the basis of the lab for that. So what we're going to have for this part, we'll have a light source, and the light source will be on the right. So light. Then we're going to have one polarizer 1, one polarizer 2, and then a sensor. So this is the sensor as we'll be doing. So that's for the first part. For the third, and so what we're going to do is rotate one relative to the other. For the third part, we're going to look at having these two like so, but then putting a third one in front of the other two between the sensor and rotate this around, and then we'll put it in between the two and rotate around and see what the effect of that is. So that'll be for part 3 for the lab. So I'm going to go through the whole part, explain, take all the data, and you'll have the data for. All right. I'm going to be doing lab 9 today, and I'll explain what we're going to be doing. This is intensity of light and polarization. So I'm going to demonstrate, I'll do the lab, but I need to have lights off to be able to do it, because we do not want the background light to be part of the data. So what I'm going to do is we have a light source, which I'm going to put on here, and so I have it at this point at 120. So I have this scale that we've used for other labs. And we have this light sensor, which I'm going to put at different distances. And I will put in data here, and we'll get the value from there. And we'll take it during for each part. And we're going to do 10 centimeters. So this is the handout you can get online. Okay. As far as lab 9. And so I'll do 10, 20, 20, 30, 40, all the way up to 90 centimeters away from the light source. So what I'm going to do is start the light source up here, 10 centimeters away. But to be able for you to see the graph as I do it, so you can actually see the data, I'm going to turn off the lights and zoom in on this part. So what I'll do is do 10, 20, 30, 40, and so on. So you won't be able to see the lab part, but you'll be able to see the screen with the data, and you'll be able to get it from there. Okay? So I'm going to move on to that part. Okay, so now I'm going to start taking the data. So I have the light source is 10 centimeters away. So what I'm going to do is collect and enter 10, and then keep. Okay. Oh. All right. All right. Next thing I do is then move it to, so you have 10 centimeters and 3013 for a value. Right? So next we're going to do is move it to 20 centimeters. The distance, so we're going twice as far. And enter that. Put in 20 centimeters. Okay, so you see our flux is 837 at a distance of 20 centimeters away. All right, I'm going to change our scale here, so we put this up to 100. So let's start seeing our data. So there's our first point or second point. Okay, we're now going to go 30 centimeters. Okay, keep that. Okay, so we get for 30 centimeters, 391 lux. That's a unit of, so now we're going to go up to 40. So that's a distance from the light source to the Okay, it's 40 centimeters. It's 225. Now go up to 50. Okay. Okay, so for 50 we have 151. We'll now go up to 60. Okay. To keep. Okay, 60 we get 111. We'll now go up to 70. All right, that's 70. All right, then we go up to 2 more. Oh, 1 more. Now we're going to do 90. Okay, that's the last point we'll do. All right, so there's our data. So there's our points for all those 3011, 839, 391, 225, 151, 111, 85, and 49. Now what we can do is, we want to try and fit this with some data. Curve fit. All right. What we might see is this I'm going to try an inverse square, and there's our fit. You can see it fits extremely well. So there's our curve, there's our data. You can see how the light with a inverse square, that's a fit. I could try it with another fit, try just inverse relationship. That's an inverse. This one, the second one here is an inverse relationship, meaning we're going as 1 over x. And you can see the fit is not very good. So I'm going to get rid of that. And what we see is that a 1 over x squared, or dx squared, is the fit. So we have a inverse square fit for this data, which is consistent with what we expect for radiation that spreads out uniformly. So that's the first part. So I'll set this down and we go on to that. So you have the data for first part. All right, for part 2, what I'm going to do here is I have one polarizer at 0, Again, 0 means the angle over here is going to be 0, and the second one is going to be at 90 degrees. I'm not going to pull them out, but that's where the second one will be. Oh no, I'll start at 0. Start at 0. Have them both at 0, and I'm going to leave the first one at 0, but for the second one, I'm going to rotate that 15 degrees, going from 0. So that'll be the data for here. So I'm going to rotate it 0, 15, 30, and so on, and get the data from that. So we're going to see is what happens. This is the light here. As we had from the first part, without anything in between, all right, the light is unpolarized. I mean, the light is polarized, but since the light source is unpolarized, this becomes polarized in one direction. What is that effect? If we then put that light, polarized light, through a second polarizer and change the angle. So we're going to go 0, 15, 30, 45, and so on. So this is for part 2. And then what I'm going to do is actually take the data with the lights off. So I'll be just focusing on the screen. And that'll be for part 2. All right? All right. As I just explained, we're going to be now doing the second part of the lab for polarization of light. And what I'm going to do is the first thing, what we're going to do is I'm going to have one polarizer. I showed you the setup for how the polarizer works, and the polarizer only allows light in one direction. And so what I'm going to do is rotate this light, this thing, and to give you a sense of how this thing works. All right. As I rotate this, I'm getting the light changes. Because as it turns out, the light from a computer monitor is actually polarized. So as I rotate this, it goes from light to dark and back again. What I'm going to do is first, got the illumination here, and we'll have the angle with this. So what I'm going to do is first rotate this around using the light from the light source, as I just showed you. And notice how the value barely changes, which means that the light from this light source is unpolarized. And so, meaning the light in any direction is the same, so I'm going to get the same sense. So what I'm going to now do is then put a second polarizer in place. First one, and I'll put a second one in between the two, as I just demonstrated earlier. And then what I'll do is have them both at 0. And I'm going to do, notice how if they're both lined up in the same direction, I still get around 200 for the intensity. So what I now do is, and much like I did with the intensity, I'm going to collect this and keep, and put in the angle is 0. And that's my intensity. So when they're both lined up in the same direction, I get the maximum intensity. I'm now going to go to 15 degrees angle. And do that. Okay. 15. Then I'm going to go to 30. Notice how the angle as I rotate one, I'm keeping the first one fixed at 0. Okay. Okay. Then I'll go to 45. I'm just going 15-minute degree intervals. Okay. 45. And 60. Then 75. Then 90. At 90, the light, when they're both at perpendicular to each other, the light basically goes down to 0. Now I'll keep going. 105. Okay. Then 120. Then 135. Then 150. And 165. Then 180. So now they're exactly opposite each other. Okay. Okay. Now I'll keep going. 195. Might get a sense of the pattern we got going on. I want to change the scale here so you can see it a little easier. Oops. Never mind. All right. Let's see, what are we up to? Up to 210. Yep. Okay. Then we're up to 225. And we're up to, and we're at 240. Getting almost done. All right, then 255. All right, then 270. And back, so we're now perpendicular again, 285. To 300. Okay, and we'll do 315. Okay, then 330, almost done. $345. And finally, 360. Back to where we started. And there's our and I'll change the scale a bit. So there's our scale. You can try fitting this, as you might think. This might be try this with a sine curve, and notice how well the fit curves. So sine or cosine curve fits extremely well with this data. So that is the second part of Lab 9. I'll next do the explain the last part and go from there. All right, so for part 3 of the lab, where we're looking at light with third polarizer, right? We're going to have here for this part, we're going to have polarizer in front of both, and for the second part where they're both in between. And so what we're going to do is, for the third one, right, for this part, we have this first one is at 0 degrees. The second one is at 90 degrees. So as we saw earlier, when this one is vertical and this one is perpendicular to that, no light gets through at all. And so what I'm going to do for the first part, and then I'll do the data, do this with here, is for this first part here, I'm going to leave it in front, meaning it's between the sensor and the other two. And I will then rotate this around and see going from 0 all the way around and find out what angle, what happens here. So we'll see this for part 1. For the left table of part 3. Then what I'll do is then set this back to 0. And so you can see the angle. So as I rotate it, 0, 90, 180, 270, 360, I'm then going to put it in between the two. And this will be the right side of part 3 for the data table. And what you're going to then see is what happens as I rotate it 15, 30, 45, and so on. So this is in between. So the first part, for the left table, it's over here, and the second part's here. So you'd think it would make no difference. Without this in between, no light goes through. But if I put this in between and rotate it, start at 0, 15, all the way down to 180, you'll see what data we get there. So that's part 3. All right, so here's part 3, and we've got the set up, taking the data for here. So I have the first polarizer at, as I marked earlier, at 0, bought them both at 0. So what I'm going to do is now rotate this around and see what happens. So as we saw, when we had just one polarizer and rotated it, nothing happened. But when we have two and we rotate one, we get a point where it gets smaller. And the minimum at about 1 is when the second one is at 90 degrees. So when the first one's at 0 and the other one's at 90, as we saw before, then we have, they're perpendicular to each other. So light from the first one cannot go through the second one, so we end up with nothing. Now we're going to try what we explain a little bit differently. Is to put in the third one. And put that at in between the other two. We're going to put it in between the other two. So it's kind of an interesting trick we're going to see here. And oh, yeah. So we're going to do the first one is we're going to put in between so that As I explained, the first, for this, in front of, as we see for here, in front of, meaning the third one will be between the light source, the sensor, and the other two, as I explained. So now what I'm going to do is I can just rotate this, and I'm not going to do anything that other than rotate it. So this is when the first one, the third one is between the light, the sensor, and the other two. As we see, we get nothing. Nothing changes. So the light for that setup, it's 0 the entire way. Now I'm going to do is put it in between, as I explained. Put them both at all at 0. Put that one at 0. And leave the other one at 90. So the only thing I'm changing is putting the third one in between the other two. So for this part of the data, right, I'm putting it in between 1 and 2. And I'm going to rotate that 90 degrees, 15 degrees at each time. So the other two are perpendicular. And I'm going to start with it at 0. Okay. So keep in mind, this is different than we had before. So the angle's 0. Okay. I'm going to do 15 degrees. All right. To keep okay. Next I'll go up to 30 degrees. Okay. Okay, now at 11, and now I'll go up to 45 degrees. And all I'm changing is the angle of the one in between. Both 1 and 2. 1 is at 0, 2 is at 90. So normally we should expect no light to come through at all. But having in between, we are starting to see something happen. Okay. Now we're going to go up to 60. Okay. Then we'll go 75. Then we'll go up to 90. Okay, then we're going to go to 105. Then we're going to go up to 120. and 135. Okay. Then we'll go to 150. Almost getting done. Okay, 150. $165. And I should say part of the reason, our intensity is less, so I'm going to have to scale this up when we're done. And then 180. So we have 1 is at 0, 2, 3 is at 180, and 2 is still at 90. Okay, so that's our data. All right, and I'm going to scale. And you can see our data. I could even, so, and this fits a sine curve pretty well. Notice when we had number 1 in front, number 3 in front of both of them, or between 1 and 2, it was 0 all the way around as rotate. But when I put it in between the two, we get a maximum at about 45 degrees. So here's 0, 90, and I can change this to so we get the scale out. So there's 45, 90, 135, and 130 and 180. So that's when we have 3 with 1 in the middle. So that's lab 9. You can answer the questions, sketch out the graph, and go from there. Okay? So